Okay, hi guys, it's Dr. Borthwick here. Just to sort of recap a little bit on ions, target diagrams, and a little bit about notation if anyone's struggling with any of those. So just to quickly recap on using these slides from before, the atomic number is always the lower number, and it's the number of protons in any given element. That never changes. I know I made a mistake in the worksheet for the lithium one. That should be 3 all the time. And the top number is the mass number, which includes the number of protons, add on the number of neutrons. Now, in any neutral element, the number of protons always equals the number of electrons, so that number is always going to be the same. However, in ions, this is where it varies. So ions basically try and make a full outer shell. So all metals, in order for them to make a full outer shell, will lose electrons, less energy required for that. So if they've got less electrons but the same number of protons, they become positive. Non-metals, to make a full outer shell, will add on electrons. If you're adding on negative, you're going to become more negative. So, quick example of that. You look at the fluorine atom. You've got electron arrangement according to page 6 of your data booklet is 2, 7. So 2 in the inner shell, 7 on the outer shell. Now think of the big shells as a mini 8-seater minibus. 4 double seats. First 4 electrons go into the outer ones. 1, 2, 3, 4. Then the 5th one has to pair up. 5, 6th one pairs up. 6, 7th one pairs up. 8th one's all by its the 7th one's all by itself. So 5, 6, 7, and you don't have an 8th one. So that means you have this fluorine and you have the fluorine atom. Now, fluorine ion, you gain an extra electron. Okay, so if you've got an extra electron, you're going to be F minus. Now, if you look at the sodium one, the next one, same idea here. Here's the sodium. You've got Na. Now, in this case, when it forms an ion, the easiest thing for it to do is just to lose 1 electron. If it just loses this little outer electron, much easier than gaining 7. So you leave that, lose that electron, it is now Na plus. Okay. Now, I realise that the target diagrams are probably going to look the same, but you want to make sure that you write out the notation for each one. So I'll do the first one for you here. You've got, so the nucleus, you've got 11 p's, you can't fit it in there, and you've got 12 neutrons. Do not try and draw them all. You just want to know the electrons. So how are the electrons arranged? Well, I've got 10 electrons, so that means there must be 2 in the middle, 8 in the outside one, the second one. So I've got 2 in this one. You can put them together, you can put them far away. It doesn't matter for the inner shell. Second shell, oh, that's really bad. It doesn't matter. So I've got 8. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Now, so I look at this and I've got 11 protons. Atomic number 11 is sodium. I've only got 10 electrons, so that means it must be Na plus. Okay, right, hopefully that helped a little for a few of you that are still struggling with this particular assignment. Thank you.